Welcome to the Databricks Skill Builder series. We're glad you're here.
Okay, let's get started. So before I dive into the details on MLflow, I just want to briefly talk about the motivations behind this invention of this project. So when we talk about machine learning, it's not only about training and testing models, there's also the data component. You will need to think about how to get the right data, clean the data, transform them, and then do some feature engineering to generate the right features for your models. When you start training the model, you need to think about how you can track and record all the parameters, the metrics, and any other artifacts related to your model runs. After that, you also need to think about how you can deploy the model and then monitor the model's performance in production. So all these things need to be taken care of and managed all together. You can, of course, manage all these things manually, but MLflow will provide you a easier and better way for you to manage all of these things. So what exactly is MLflow? It is an open source platform to help you to manage the end-to-end machine learning lifecycle. It's not the machine learning code itself. Instead, it's a framework to help you to operationalize data science and machine learning workloads in a more standardized way. And it's available for everyone to use regardless of the platform you're on. And that's what's meant by it's open source. On Databricks, we provide a fully managed and hosted version of the MLflow, which is highly integrated with enterprise security features. It's highly available and also works with a lot of other Databricks workspace features. It works with most of the machine learning libraries and frameworks and supports Python, Java, R APIs. You can also leverage Databricks CLI and REST APIs to interact with the MLflow. There are 4 key components that are organized into MLflow, including tracking, projects, models, and model registry. You can use each of these components separately or on their own, but it's better to use them all together because they're designed to work well with each other together. First of all, MLflow tracking is an API and UI used for logging parameters, your code and data versions, metrics, and any other artifacts when you're running or training your machine learning model. And you can also utilize it for later visualizing the results. You can use it in any environment, for example, in a standalone script or a notebook to log the results to local files or to a server. Then you will be able to compare all the different model runs side by side and select the best models. Teams can also use it to compare results from different users. The second component is the MLflow project. It is a standard format for packaging your data science or machine learning code for reusability purposes. Each project is simply, you can think of it as a directory with code, or it can also be a Git repository, and uses a descriptor file to specify any dependencies or requirements, and also how you can run the code. For example, projects can have a conda YAML file in the directory for specifying the Python conda environment. When you use the MLflow tracking API in a project, MLflow can automatically track the project version and any parameters. You can also easily run any existing MLflow projects from GitHub or any remote repository and chain them together into multi-step workflows. Next, on MLflow models, this is a conventional way to package your machine learning models in different flavors and a variety of tools to help you to deploy them into different environments. Each model is saved as a directory within your MLflow project that contain arbitrary files and a descriptor file, which contains the metadata and lists several flavors of the model that the model can be used in. And flavors are basically some conventions we use that separate deployment tools can recognize them and understand the models if you were to deploy them in those environments. For example, if you have a TensorFlow model, that can be one of the flavors of an MLflow model, and it can be loaded as a TensorFlow DAG or it can be also loaded as a Python function. So you can apply to your input inference data when making predictions. MLflow also provides tools to deploy many common model types to different platforms. For example, any model supporting the Python function or PyFunc flavor can be deployed to, for example, Docker-based REST server or any cloud platforms such as Azure Machine Learning or AWS SageMaker. You can also have it as a user-defined function in Spark for either batch or streaming inferences. Finally, the last component, MLflow registry. This is a centralized model store for you to save all of your models and versions in a centralized location, and helps you to collaboratively manage the full life cycle of an MLflow model. It gives you model lineage information. For example, which MLflow experiment did you run to generate this model, as well as model versioning and stage transitions. For example, you'll be able to easily transition from one stage to another, from staging to production, or even archiving the model if you're retiring a model version. Well, as I mentioned before, today I'll more focus on the tracking aspect, but all these components all play into each other, and it's better to utilize all of them together when it comes to operationalizing your data science and AI workflows. So if we take a look at the machine learning lifecycle in a holistic way, we start by training and developing models and even tuning hyperparameters, and then compare the metrics to select the best models. And you can leverage different flavors of MLflow models. We then try to track all the models and any relevant artifacts with MLflow tracking capability. And then we save the models to our centralized model registry, and being able to transition these models between different stages, depending on which version you use. And finally, we can deploy the models for either batch or online inference in different environments. So in summary, MLflow really gives you a managed and standard way to govern and track your machine learning life cycles, and you'll be able to deploy them very easily in a standardized and packaged way on either Databricks natively or in container environments in Docker or any other model hosting applications. The next section will be more on the details of MLflow tracking and how you track everything within an experiment. So before I jump into the details on this section, I would like to pose probably a question to the group. And since you can't answer, you can think about this question as you're watching the webinar. So think about when your data scientist on your team is building out a model, how do they usually track all the input parameters that they use to test on different model runs? And also how they actually organize and store all these metrics and results of each of the model runs.
If you actually want to raise your hand, we can go ahead and unmute you if you would be willing to share how you or your team currently tracks your machine learning parameters and things.
Yep.
Go ahead, Megan.
Oh, hi. This may be an immature, not very standardized method. So basically, our infrastructure is mostly on AWS, and our machine learning environment is actually a centralized EC2 instance that has a data science hub in it. So we involve a lot of times the S3 buckets so we have workflows and pipelines at every step that outputs the model results, training results, and then save the model and archive them in the S3. And then we just basically access the S3 buckets at different steps to do basically training, parameterizing, scoring, all of those. So it's not as standardized as this kind of like a enterprise level solution that we're seeing here. So, but just for sharing.
Awesome. Thanks for sharing, Megan. So yeah, that's more of an advanced way of saying saving the results and artifacts in S3 bucket. But for a lot of customers that we talk with, they still stick with most of the traditional ways of saving these artifacts or parameters. They sometimes might use Excel sheet. For example, they will basically just track all the hyperparameters for each of their model runs in Excel sheet, and then also the metrics associated with each model run. And of course, this way works, and it's kind of manual and can work in case when you have a small number of models. But when it comes to production level models and for large enterprises, you might have a lot of models in pipeline and production. So it will be hard to manage all of these different related informations for each model runs. And essentially it will be hard to scale. And that's the basic motivation behind this experiment tracking aspect of MLflow. And we'll see how exactly it achieves all the model tracking of hyperparameters, metrics, and everything else associated with model runs in a much more scalable and manageable way. So as I mentioned, MLflow tracking is one of the major components of MLflow. It's the logging API that's designed towards machine learning, and it's agnostic of any libraries or environments. So experiments are basically the primary unit of organization in MLflow. You can think of them as high level or umbrella kind of projects, which will contain all of your different model runs, whether you're running different runs to compare hyperparameters and select the best model, or you're just trying out on different algorithms to come up with the best model. And each experiment can allow you to visualize, search, and compare all these different runs within it. And you can also download any artifacts or metadata related to a specific run later on for analysis in other tools. Here are 4 different components or key aspects that can be recorded for each model run. First of all, parameters. These are key value pairs of your input parameters or hyperparameters. For example, it could be the number of trees or the max depth of your tree for a random forest algorithm. Secondly, it can also record metrics. These are the evaluation metrics or error metrics you can record to evaluate your model performance. You can also record any other artifacts with the experiment. These artifacts can be files in any format. For example, they can be images, pickup files, or any data files. Last but not least, you can also log all the sources. In other words, the code or notebooks that you use to run the experiment with your MLflow experiment as well. So everything related to tracking is achieved through the MLflow tracking server. This is hosted on the Databricks side of things. It can help you to keep track of all of your models and reproduce them. Anything that you run in the notebooks can be an input in the tracking server. And in addition to that, you can also track anything from a local machine or from any type of cloud. So it doesn't really have to be on Databricks. So it makes it a lot more flexible for you as well. The MLflow tracking server is hosted, as I said, on Databricks side, but it's made available to the users via 3 different ways. The first one is through the UI. So if you're not a coder, you just want to interact with the MLflow server, tracking server, you can basically just do point and click through the UI instead of writing code to launch all the functionalities. Secondly, if you are a programmer, you can access MLflow tracking server through the REST API, which also allows you to launch all the functionalities. And lastly, you can also access the tracking server through a Spark data source. So how exactly can I log the parameters, the metrics, the models themselves, as well as other artifacts under an experiment? The most traditional way to do it is through manual logging. For example, I have a code snippet right here on the screen. When you start a MLflow run, Within it, you train the model, fit the model on the training data set, make predictions on the test data set, also calculate the evaluation metrics based on your preference, and to log each of the items that you would like to save with your MLflow experiment. You can invoke all these different functions. For example, log underscore param can help you to log any input parameter. It can also be log params, so to log a set of different parameters within the same function, and then log metric for logging evaluation metric, and then log model to save any models with the preferred name that you specify. Alternatively, you can also leverage Databricks auto logging. And this is basically one single line of code in place of all the different logging functions that you have to launch to automatically help you to log the parameters, metrics, any arbitrary files or lineage information. And all of those can be tracked and captured automatically. When you attach an interactive Python notebook to a Databricks cluster, Databricks auto logging can call this MLflow.autolog to set up tracking for your model training sessions. When you train models in the notebook, model training information is automatically tracked with MLflow tracking. Additionally, there's also this aspect for reproducibility that comes with auto logging. It can keep track of the environment dependencies, such as your libraries that need to be installed, cluster configurations, your data and code versioning, so that the same run could be easily reproduced by cloning the run. So if you can see on this diagram right here, there will be a reproduce button right here that you can clone the notebook and attach it to a cluster if you want to reproduce that experiment. So this is more on the project and model side of things, even though the focus more is on the tracking side, but I still want to just briefly go through the models and projects aspect because all these components are really interconnected with each other. It's better to be used all together. So on the MLflow project side of things, as I mentioned before, that on the definition, MLflow project can bundle all of the different elements related to a model run, specifically the environments and requirements libraries used to train the model in a standard way. On the slide here is an example MLflow project. You have a project folder in the directory. We have the Conda environment file as a YAML file. We also have the different code scripts that are used to train and test your model. You can take these projects away and deploy them or reproduce them very easily in any other environments that can recognize the different flavors under the MLflow models. Then for the models themselves, the MLflow models are basically a media between all these different machine learning libraries or frameworks and these downstream deployment environments. It connects these two moving pieces together, give you a standardized format to deploy different machine learning frameworks into different environments, whether it be a Docker environment or a UDF in Spark or any other model applications like SageMaker or Azure Machine Learning. So here's a sample MLflow model right here. You have this ML model file, which contains some of the metadata. In this case, we have two different flavors attached to this model, the TensorFlow flavor, the Python function flavor. So this means in any deployment environments, as long as they can recognize TensorFlow and Python function, the model can be deployed in those environments. So I'm going to pause here for a second before I jump into the demo. Are there any questions or comments? Or if anyone is open to share any experience on training and managing models and how you do those today in your company? Happy to listen to any ideas or comments. Well,
Go
Oh,
ahead.
sorry, I do have a question. I was typing it out in the chat, but it was a bit slow. So my question is, I saw that this registrar actually involves mostly for the model training setup. So does that also involve like data processing and data engineering, feature engineering, all of those? Like, could that be also incorporated into a coherent flow? This,
a good question. So on Databricks, we do have a native feature store that can integrate with MLflow. So you can develop all of your data processing or feature engineering logics on your own, and then pre-compute those features and save them into a centralized feature store location. So you will be able to search, discover any features that others have developed in the feature store, and each feature store, the feature store has a lot of feature tables that others developed, which has a lot of lineage information telling you which data sources are used to prepare those features, and also what are the downstream consumers, such as the models, or if you have a job that are using those features. And with MLflow, there is a specific feature store API that integrates with MLflow, and you will be able to package all of your featureization logic within your MLflow model as well. So when you're doing model inference, for example, batch inference, the model can automatically look up the features from the feature store using that featureization logic that's saved alongside with the model.
excellent, got it.
So now if there's no other question, we can jump into our demo, and I'll show you how exactly the tracking component works with MLflow. So I'm here in the Databricks environment. For those of you that haven't tried out Databricks yet, this is the standard environment where we do all the code and stuff. A notebook environment, if you're familiar with Jupyter Notebook, it's very similar. But on top of that, we also have all the versioning available for the notebooks, and you can also set up your remote repository to save all of your notebooks and do CI/CD version control from there as well. So today I'll be focusing on the experiment tracking aspect. First of all, I just need to do some setup right here to make sure all of my notebook environment variables are set up so I can use all of them. The data set I'm using here is a popular Airbnb data set, which contains all of the listings as well as the pricing for each of the listings. It's basically a CSV file, and I'm just reading that file in here into a pandas data frame. And for a typical component of a data science workflow, we will need to split our input data set into a train and test data sets. So we fit the model or train the model on the training data set and evaluate the model on the test data set. So here I'm just splitting the input data set into the training and test data set. And the price column will be the target variable I'm using to make predictions. In this case, it will be a regression problem where I'm trying to predict the price of each of the Airbnb listings. One thing to note is that when you are setting up or start an experiment within a notebook, there's a mapping between the notebook and an experiment. The experiment ID and name will be the same as your notebook's name. So after we prepare the data, and of course, I ignored a lot of the featureization logics or any other data pre-processing, but you typically will need to do that on your own before you have data ready to be used for training models. But here I just assume my data is clean and I have all the features standardized and all worked out to be usable for my machine learning model training. So here I'm ready to use my training data set to build my model in this case. So when I'm ready to train the model, I can start invoke the MLflow run experiments. Before I do that, I just need to import a couple needed or necessary modules right here. In this case, I'm using the sklearn flavor of MLflow and also more specifically the random forest regression algorithm. And also I will be using this mean squared error metric to evaluate the model. So to start a MLflow run, you basically just need to write this line of code with MLflow.startRun. The run name is optional, but it's highly recommended because it's highly unlikely that you will only conduct one run within an experiment. You usually will need to do multiple runs to compare the results. So giving a name when you start a run, it will be easier to compare different runs and distinguish among them. Now within this MLflow run, you should be able to start fitting your model and train it, and then make predictions on your testing data set. Then after the model training is done, you will be able to log the model. In this case, I'm doing all the logging manually. Just want to show you how the logging works. You can specify a name to the model when you're saving it. And then I'm calculating the metric, the MSE, using the actual testing data set as well as the predictions on the test data set. I'm also printing it out, so it's also printing to the console in the notebook under the notebook cell. And I'm logging this MSE metric by giving it a name, MSE. Finally, I also want to save the specific run ID and the experiment ID. These will be really important and basically the access or entry point for you to retrieve any model run related information through the API if you want to retrieve everything through the code or in a programmatic way. Finally, I'm just printing out the ID and the experiment ID right here. And you will see in the console, it actually prints out what's the MSE and also the run ID and experiment ID. Alternatively, as I mentioned in the slides, you can do one-liner of code auto logging. It's currently available for these set of different machine learning frameworks. And of course, we are continuously developing and working on expanding this network. So there will be more networks or frameworks supported in the future for the auto logging perspective. Now, after you successfully train a model within an MLflow model run under an experiment, you should be able to see something printed out in the console or a notification saying logged one run to an experiment. And if I click on this experiment link right here, it should navigate you to the experiment tab. Make this a little bit bigger. You can ignore the first two runs right here, but just looking at this run, because I only logged the one run so far. Those were the other runs that were logged for the following code. So if you just look at this run here, this is the run that I just logged. It took 10 seconds to complete, and the run name is the one that I specified. It's linked to the source notebook that's used to track this experiment, and also has the model that's logged, the metrics, which I logged, and MSE. I didn't log any parameters, so nothing under the parameters section. If you want to learn more details about this run and see what files and other stuff are logged within this run, you can click on the start time, the timestamp right here. And it will navigate you into this specific run page. On the top, you have this reproduce run button, which you can easily reproduce this model run and some metadata on the top. You can add a description. You can also add a tag. But more importantly, on the bottom, there are all these different files that are automatically logged with your MLflow project. So the first one is this ML model file. This is the metadata file related to your model. It has the different flavors associated with your model, and also has some artifact path and what version of Databricks runtime is used. And by the way, Databricks runtime is a pre-packaged software that's installed on all the Databricks clusters by default. They come with, for specifically machine learning runtimes, they come with most of the popular machine learning frameworks, so you don't really need to reinstall them again. locally, and also they integrate highly with MLflow. And there's also the regular version of Databricks runtime, which is more geared towards data processing or data engineering. If you're using that version of Databricks runtime, it's required that you pre-install MLflow, because that doesn't have MLflow pre-installed. Then we have the conda file, which gives you the Python conda environment requirements, and it's a YAML file. The pickle file is the actual model itself. Then finally, the requirements is a text file that has additional pip dependencies. Now going back to my notebook, let's try to log more artifacts with another run. So if you recall before, I didn't log any parameters. So this time let's try to log more parameters and some other arbitrary artifacts. So this time I actually wrapped all of my model training code and my MLflow experiment tracking code within a function. So it's reusable. And oftentimes it's very common for you to do multiple runs. So I just need to pass the experiment ID, my run name, parameters, my training and testing data set. I want to log all of my different runs under the same experiment. So I'll just use the same experiment ID for all the runs that I'm conducting within this notebook. And same thing, when you want to start an MLflow run, you do this line of code MLflow.startRun, and I'm using the same experiment ID as the previous run, but this time just give it a new run name so you can separate it from the previous run. And same thing as before, I'm fitting the model, making predictions and logging the model, call it as random forest model. In addition, I'm also logging the parameters this time. For metrics, I'm also logging 2 additional metrics on top of the MSE. Also, feature importance can be very useful when it comes to evaluating a model. In this case, I'm retrieving the feature importance from my model estimator and then put it into a data frame, exporting it to a CSV file, and then finally log it alongside with my MLflow project with all the other stuff that are already logged. For any arbitrary file that you want to log with your MLflow experiments, you can simply just do log artifact. So any type of files or in any formats can be logged. Finally, I also want to do a plot on top of the feature importance. So I also log that feature importance graph alongside with all the other stuff. Finally, I just return the run ID for my specific model run. So later on, I can retrieve any details if I need to. So to initiate my new run, I will simply just need to call my log rf function by passing all the needed parameters or variables to the function. And I just gave it a new name as second run. And here's my parameters dictionary, which contains basically just 3 input hyperparameters to my random forest regression model. And you can see right here, after I invoke the run by calling the model, the feature importance graph is printed out in the console as well. So now if you go back to the experiment tab, there should be 2 different experiments, 2 different model runs listed under your same experiment, basically the second run and this basic RF experiment. If I click on this timestamp, will again navigates me to the details for this model run. And this time you will be able to see there are 3 different parameters locked compared to the previous run where I didn't log any parameters, and also 3 metrics logged right here. More importantly, you can see there are the additional feature importance CSV file that I logged with my experiment in this case, which gives you a list of scores for each of your features. I also have my feature importance graph that I plotted, and that's also saved alongside with your MLflow project. So this really gives you a easy way to manage everything that's related to your model, MLflow model project. So everything can be all saved and logged together alongside all the other related artifacts with your model. So when you want to pass on this project to someone else, they have everything that's relevant to this model as well, and will be very easy to be able to reproduce this model or deploy it in a different environment. Now, oftentimes people will try, or data scientists will try different set of input parameters and then compare the model results to see which one gives the better performance. And that's involving the hyperparameter tuning stuff. So here I'm just trying to do another run with a different set of values for my input parameters and see how the performance come out to be. And then I can compare all 3 different runs side by side to see which is the best model I can choose and potentially use it for production or further testing. So here I'm just recalling my same function, model training and MLflow tracking function by passing a different set of parameters and give it a different run name. After you run this cell, you should be able to have another run logged under the same experiment. So going back to my experiment tab right here, now you should be able to see all 3 runs side by side. So you should be able to compare them all together on the metric side of things and also on the parameter side of things. There's also a built-in functionality for you to compare different runs in a visual way. So for example, if I select all different runs together and hit on this compare option right here, will lead you to a new page, which it will give you, make this a little bit smaller so you can see the whole graph. So on the top, there will be a graph that tells you how these 3 runs compare in terms of the hyperparameters and then the model scores or the evaluation metrics. And there's also details related to each of the runs. Finally, there are also tabular comparison available for you to compare the parameters and metrics. So this will be very easy for you to evaluate which model will be the best candidate for the next stage, especially when you have a large set of models. You can easily compare them side by side. And then oftentimes there are programmers who want to access all these experiments or runs information through the API. MLflow also offers this REST API for you to retrieve all the related information for your past runs or experiments. The way to interact with it is through the MLflow client. First of all, you will need to import MLflow client from the MLflow.tracking module and instantiate it. There are all different kinds of information you can retrieve from the using the MLflow API. For example, I want to list out all the information related to each of my runs under the same experiment. You can basically leverage this function, the list run info, for a specific experiment ID. Then it's going to give you all the metadata related to each of the model runs. You can also list out all the artifacts related to a specific run. So you just need to provide the run ID for that specific run. So it's going to list out all the related artifacts. So you can see it's important to record the experiment ID and run ID, just so that later on you have those information to retrieve any model runs and experiment runs related information. You can also load in the runs details into a Spark data frame. And this will be very similar to the list run information, but it's just populating everything into a data frame gives you extra metrics, parameters, information, and also all the default tags you have on for each of the runs. You can also list all the runs and order the runs by their start time and retrieve For example, in this case, I'm trying to retrieve the most recent run I conducted within the experiment, and also list out all the artifacts related to the most recent run. Metrics is also available for you to retrieve through the run ID as well by using the getrun.data.metrics. And finally, we can also reload the model back into memory. And if you want to retrieve anything related to the model itself, you can do that on top of the model directly as well. In this case, I'm just retrieving some feature importance, the raw feature importance array from my model itself. With that, this is pretty much what I have for today's session. Are there any comments or questions? Let me recheck the Q&A or the chat box. I guess a lot of times people ask questions about how does auto logging work, what kind of things are actually logged with auto logging. So everything we talked about, the hyperparameters, the results, the models themselves, everything that you can log manually are going to be automatically logged with your auto logging. Besides any arbitrary files that you want to log. For those, you will still need to log them manually because we won't know by default which other artifacts you want to log. But to enable that, you will need to change one option within the auto logging function, which is an exclusive parameter, and turn that to false so that you can also log additional artifacts on top of the artifacts that are logged with auto logging. Are there any other final questions or comments from the audience? Well, if not, I would encourage you to check out both Databricks documentation on MLflow, as well as the open source MLflow website. If you want to learn more about MLflow, it's a pretty flexible framework. You can not only track all the already built in ML frameworks, but you can also write your own code and have your own version of custom models and also track everything related to your custom model as well. And that will just be achieved through the PyFunc layer instead of the already pre-built in flavors for each of the machine learning frameworks.
Hi, we have a question in the Q&A. If you can take a look.
Yep, let me see. Sure, yeah, I can share the demo notebook afterwards via email. All right, I guess if there are no other questions, thanks everybody for joining today's session and your participation. We look forward, we have a series of webinars coming up on different topics, and we look forward to seeing you all there. Thanks, Amin and Mimi. Have a great day, everyone.